Measurement. Measuring things including lengths. Learning objectives. After watching this video, you should be able to 1. Identify the base quantities in the SI system. Point 2. Name the most frequently used prefixes for SI units. 3. Change units here for length, area and volume by using chain link conversions. Fourth one, explain that meter is defined in terms of the speed of light in vacuum. Measuring things. We discover physics by learning how to measure the physical quantities involved in physics. Among these quantities are length, time, mass, temperature, pressure, and electric current. We measure each physical quantity in its own units by comparison with the standard. The unit is unique name we assign to measures of quantity, for example meter, that is small m, for the quantity length. The standard corresponds to exactly 1 meter unit of the quantity. As you will see, the standard for length, which corresponds to exactly 1 meter, is the distance traveled by the light in a vacuum during a certain fraction of a second. We can define a unit and its standard in any way we care to. However, the important thing is to do so in such a way that scientists around the world will agree that our definitions are both sensible and practical. Once we have set up a standard, say, for length, we must work out procedures by which any length, whatever, be it the radius of hydrogen atom, the wheelbase of a skateboard, or the distance to a star, can be expressed in terms of standard. Rulers which approximate our length standard give us one such procedure for measuring length. However, many of our comparisons must be indirect. You cannot use a ruler, for example, to measure the radius of an atom or the distance to a star. Base quantities. There are so many physical quantities that it is a problem to organize them. Fortunately, they are not at all independent. For example, speed is the ratio of length to a time. Thus, what we do is pick out by international agreement a small number of physical quantities such as length and time and assign standard to them alone. When we then define all other physical quantities in terms of these base quantities and their standards called base standards. Speed, for example, is defined in terms of the base quantities length and time and their base standards. Base standards must be both accessible and invariable. If we define the length standard as the distance between one's nose and the index finger on an outstretched arm, we certainly have an accessible standard, but it will, of course, vary from person to person. The demand for precision in science and engineering pushes us to aim first for invariability. We then next great effort to make duplicates of the base standards that are accessible to those who need them. Thank you.